Welcome to Linear Equations Level 5. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving the equation minus 2 multiplied by x minus 1 minus a half x is equal to 3x plus 5. Now on the left hand side of the equation we've got brackets within brackets, so we're going to start from the inside and work our way out. So the left becomes minus 2 multiplied by x, and the minus in front of the bracket is like having a minus 1 there. So we have minus 1 multiplied by 1, which is minus 1, and minus 1 multiplied by minus a half x gives us positive a half x, and that's equal to 3x plus 5. Now on the left we can simplify inside the bracket. So we have minus 2 multiplied by, and the x plus a half x become 1.5x, or 3 over 2 x. And we still have a minus 1 inside that bracket, and that's equal to 3x plus 5. Now staying on the left, we can now expand the second bracket. So we have minus 2 multiplied by 3 over 2x, which gives us minus 3x. And minus 2 multiplied by minus 1 gives us plus 2, and that's equal to 3x plus 5. Now that we've expanded and simplified, we can see that we have unknowns on both sides, so we're going to keep our unknowns on the side where we start with the most. And on the right we have 3 x's, and since 3 is greater than minus 3, we're going to keep our x's on the right, which means we need to remove the minus 3x from the left. And we do this by using its inverse, which is plus 3x, and do the same on the right. So on the left side, the minus 3x and the plus 3x cancel out to just leave us with 2, and on the right, 3x plus 3x is 6x, and we still have a plus 5 there. Now looking at the right, we'd like to remove the plus 5, and we can do this by subtracting 5, and doing exactly the same on the left. Now on the left, 2 minus 5 gives us minus 3, and on the right, the plus 5 and the minus 5 cancel out to leave us with 6x. Finally, to remove the times 6 in front of the x, we can divide by 6 and do exactly the same on the left, and minus 3 divided by 6 can be written as minus 3 over 6, and on the right, the times 6 and the divide by 6 cancel out to just leave us with x. And although x equals minus 3 over 6 would be a perfectly good answer, we can simplify minus 3 over 6 to give us minus a half. So x is equal to minus a half is our final answer to problem 1. In problem 2, we're solving the equation 4k minus 3 all over 2 plus 3k plus 1 all over 4 is equal to 5 minus 2k. Now since we have multiple fractions on the left hand side, what we'd like to do is put everything over the same denominator. And on the right, although we don't have a fraction, we can write this as 5 minus 2k over 1. And we can now see that 1, 2 and 4 are all factors of 4. So this means we can make all their denominators equal to 4. So starting on the left, we can multiply 2 by 2 to give us 4, and we need to make sure that we do the same to the numerator. The second fraction already has a denominator of 4, so we don't need to change that. And on the right, we need to multiply 1 by 4 to make 4, so we do the same to the numerator. So going back to the left, we can multiply the numerator by 2, so we get 2 times 4k minus 3, and on our denominator 2 times 2 is 4, plus 3k plus 1 over 4 is equal to, and we can multiply the numerator on the right by 4, so 4 times 5 minus 2k divided by 1 times 4, which is 4. And the reason why it's useful to make all those denominators the same is that we can now do the inverse of divide by 4, which is to times by 4, to multiply every one of these fractions by 4, so that we're just left with their numerators. So from left to right, we have 2 multiplied by 4k minus 3 plus 3k plus 1 is equal to 4 multiplied by 5 minus 2k. We've now got brackets on both the left and the right, so we can expand these, and we have 2 times 4k is 8k, and 2 times minus 3 is minus 6, plus 3k plus 1 is equal to 4 times 5 gives us 20, and 4 multiplied by minus 2k is minus 8k. We can now simplify the left-hand side by collecting together the like terms. So we have 8k plus 3k is 11k, and minus 6 plus 1 gives us minus 5. And on the right, we still have 20 minus 8k. Now we've got unknowns on both sides here, so we're going to collect them on the side where we start with the most, which is on the left where we have 11k. And this means we need to remove the minus 8k from the right, and we can do this by using its inverse. So we add 8k to both sides. On the left, 11k plus 8k gives us 19k. We still have a minus 5 there. And on the right, the minus 8k and the plus 8k cancel out to leave us with 20. Going back to the left, we now need to remove the minus 5. And we can do this by adding 5 to the left and also adding 5 to the right. And the minus 5 and the plus 5 cancel out, leaving us with 19k. And on the right, 20 plus 5 is 25. Finally, to remove the times 19 in front of the k, we can divide by 19, and we can do the same on the right. And the times 19 and the divide by 19 on the left cancel out to leave us with k. And on the right, 25 divided by 19 can just be written as 25 over 19. So our final answer to problem 2 is k is equal to 25 over 19. In problem 3, we're solving the equation minus 4 multiplied by 5g plus 7 minus 1 minus 2g all over 5 is equal to 8g plus 7. Now there are different approaches to solving a problem like this, but since we have a fraction with a 5 on the denominator, I'm going to remove this by multiplying everything in the equation by 5. And this means I need to multiply the fraction by 5, I need to multiply the bracket at the start by 5, the 8g needs to be multiplied by 5, and so does this plus 7. So if we do this and we start on the left, minus 4 multiplied by 5 gives us minus 20, and we have 5g plus 7 in brackets, minus, now although the times 5 and the divide by 5 in the fraction cancel each other out, we need to be really careful here, because it's the whole of the 1 minus 2g that is being subtracted. So we need to make sure that this goes in a bracket, and to make this really clear, we can even put a minus 1 in front of it. Now going over to the right, 8g times 5 gives us 40g, and 7 times 5 gives us plus 35. So going back to the left, we can now expand. So minus 20 multiplied by 5g is minus 100g, and minus 20 multiplied by 7 is minus 140. Minus 1 multiplied by 1 is minus 1, and minus 1 multiplied by minus 2g is plus 2g, and that's equal to 40g plus 35. Now staying on the left, we can simplify by collecting together the like terms. So we have a minus 100g and a plus 2g, which gives us minus 98g, and minus 140 minus 1 gives us minus 141, and that's equal to 40g plus 35. Now since we have unknowns on both sides of the equation, we'd like to collect them on the side where we start with the most, and in this case it's on the right where we have 40g, because 40 is greater than minus 98. So this means that we'd like to remove the minus 98 from the left, and we can do this by adding 98g and doing exactly the same on the right. Now on the left, the minus 98g and the plus 98g cancel out to leave us with minus 141, and on the right, 40g plus 98g gives us 138g, and we still have a plus 35 there. Now we'd like to remove the plus 35 from the right, and we can do this by subtracting 35 and also doing the same on the left. And minus 141 minus 35 is minus 176, and that's equal to, well, the plus 35 and the minus 35 cancel out, so we're just left with 138g. Finally, we'd like to remove the times 138, so we do this by using its inverse, which is divide by 138, and do exactly the same on the left. And on the left, minus 176 divided by 138 is minus 176 over 138, and that's equal to g, since times 138 and divide by 138 cancel each other out. And if we simplify, this becomes minus 88 over 69. So our final answer to problem 3 is G is equal to minus 88 over 69.